All right, let's talk about analog signals. First of all, that any of these things we're talking about, I do suggest you Google these things and look on Wikipedia or whatever, and follow some of these links out to expand your knowledge and branch out, as much as you think you need to for what's going on or what you think you might need for the applications you're working in. But just a basic understanding that the analog signal, the difference between an analog and a digital signal is that the analog signal is continuous. It's not broken up, and it's continuous. So that's a real simple concept to understand. If you're talking about analog signal data and storing it, we're not going to get into that. And at this point in time, unless it's for nostalgia, or you have some very specific purpose, that I don't even address that issue very much. So just the signal itself that we've talked about, and we're kind of talking about it from the viewpoint of audio, so basically we're not dealing with direct current or DC offset, so we're dealing with, AC current, alternating current that is basically going to be, a direct understanding of that is if you look at actual analog signals that are outside of the electrical circuitry that haven't been transformed from transducers into an electrical circuit, that it's basically the same thing. We've talked about acoustics, so if you went back and watched that series on acoustics, that you should have a pretty good understanding of things that may affect that signal, in the air. The analog is signal that's, just, you speaking or any sound that's out in the open. And that's a very simple concept to understand. And when it goes into your electronic circuitry that we've already talked about in the acoustics about, when you're dealing with the acoustics, that, you have the cause, the generating mechanism, transduction, the acoustic wave propagation, the analog signal through the air, the reception and the transduction. Now, the reception and the transduction is a huge part of this analog signal, because when it hits any types of a transducer, that you're going to end up with rarefaction and compression. And what that's going to do is it's going to vary the voltages of the actual current, either the diaphragm in your condenser microphone or the diaphragm in your ear or the speaker that's coming out of, but capturing it when it initially goes in there is that analog signal gets, directly related to electrical circuit and alternating current by compressing and releasing pressure on the diaphragm of the microphone, whatever transducer you're using. And basically that's the same concept as what it's doing out in the air of rarefaction and compression, but it's doing that to the diaphragm on the condenser microphone, varying the voltage, to where your waveform may be coming out looking sinusoidal and clean, with the voltages going up, back down to zero, down, up, like that, or it might be very erratic as it captures that analog waveform from the air and converts it into an electrical signal. But there's a few things like phase we've talked about, and there's a video on here about basic phase. Basic phase that, phase we're not going to really discuss it too much about it because it can be a property of it, but a lot of times it very much is, but it's not a direct property of the signal, as we're just trying to describe what the signal is. That phase is something that can happen to the signal, whether it's out in the air or inside the electronic circuitry. And if you go back and watch those videos, that you'll have a better understanding of that. So what else can happen in there? The basic understanding to understand that. So now you understand what's happening there. And distortion. So distortion can be in the analog realm, out in the open, in the air, and analogous signals, that your sound coming out of your mouth or any production of sound like that, or as it goes through electronic components, what might be happening with distortion, with added harmonic content and all those things. And, when we talk about those things, that what happens? Very simply what happens is that analogous signal gets, distorted in some way and causes the waveform to not be clean and sinusoidal to where it becomes more looking like a complex waveform. And we've discussed that. So basically, the actual understanding of just the analog signal is, the basic understanding is it's just a continuous signal. And most of the time related to audio, that it's going to be AC and alternating current, so that your transducer, like the microphone, can deal with that in compression and rarefaction to differentiate the actual voltage current to form a waveform. And the same thing with your transducer that's a speaker. When it comes back out, it does the same thing. So basically, it's trying to reproduce the complex waveform or timbre that it's capturing by that compression and rarefaction of the diaphragm. And the speaker's doing the same thing, so that it can create that waveform, recreate that continuous analogous waveform that you initially hear, just like by speaking or something like that. And it's about that simple. A lot of the complexities, if you really get into reading about analog signals, that there can be a whole lot of complexities in what's happening with it. But just a basic understanding of it, so that, when you're talking about an analog signal, what's happening, when we talked about sound, and if you've watched those other videos on sound, and that you should have a pretty good understanding from watching the videos on acoustics and some of the other videos that are on this channel, that you should have a pretty good understanding of what sound, contains. And so that analogous signal, basically most of those discussions we had were based around analog signals, whether or not they were discrete time inside the DAW, which we'll talk about in the next video about digital signals. But it basically worked out to the same thing, the same concepts we were addressing from an analogous point of view. So basically, it's about that simple, and like I said, there are a lot of things. The biggest thing to understand about it is that it is continuous. It's not, it's not samples or discrete time like digital that we'll talk about. And that, the things that happen, we've already spoken about in acoustics, that can happen to that actual analog signal, whether it's out here or in the digital realm, and the type of things that can happen to it to change it and transform it and cause it to act differently, or to shape and form differently. And I think we've addressed all those issues in the other videos, but that's just a basic understanding of the analog signal, so that you understand out in the air and inside the circuitry that it is continuous signal. And most of the time, if you get down there and look at analog signals out in the open and in the air, there's some concepts dealing with it that, that we may or may not have directly addressed in that series on acoustics. But for the most part, I think we did. And we've already talked about, how things can work inside electronics, what happens with that signal and that alternating current signal, and how it can be affected the same way it can be affected outside. And then what's capturing it, transductors and transducers that are capturing it, and basically how they capture that. And then, how it goes through the system is that, those currents and those varying voltages actually are a direct representation of that continuous analogous signal that it's trying to capture. So that's a real basic understanding, and I hope I made that real simple to understand, so that it's not confusing at all, so that when you're talking about an analogous signal, that basically they're just speaking about a continuous signal that is not broken up, and that is just basically continuous. Okay, so let's just reiterate really quickly that, when you're talking about, let's start out, and outside, you're talking about analogous signal, in the open. So we're talking about that basically, it's a sinusoid or combination of sinusoids, which can be a complex waveform at certain frequencies and amplitudes and varying. And what causes that? Well, basically what's going to cause the most important issue that you're going to deal with, other than just frequency and the timbre of it, that you can watch that video I put on this channel about timbre, is the rarefaction and compression of the actual air that's going to actually convert into a sinusoidal waveform that comes in waves. That way, that when you're looking at a waveform, it basically, like a sinusoid, that it's a direct representation of the compression and rarefaction. So what happens? So that's a real simple concept to understand, and that how that goes into hits the transducer, like the microphone, the diaphragm on the condenser microphone, and it causes what to happen? It causes compression. So if you've got a sinusoid here, this red one, that it's the voltage that from compression and release of pressure, that it's causing more voltage and less voltage at a continuous time. You know, there's no stopping. It's just continuous. And that will go up and down. And depending on how complex the waveform, it might be like this black one, to where it doesn't look as uniform as a sinusoid, but it's being caused by that compression and rarefaction. And that does what? That causes the actual AC looking waveform from that voltage, varying voltage going through there, that's making that actual current and that alternating current that goes through your electrical components. And that is the most basic way to look at an analog signal. And your ear's going to capture that just the same way as the condenser microphone, or, you know, an example, you know, a very simplistic view of it, that's kind of the way it works. And when it goes through electronics, and that analogous signal that's varying voltage goes through everything it's going through and hits your speaker, that is trying to reproduce from that varying voltage that compression and rarefaction, compression and release of pressure on the actual diaphragm on the actual speaker, that's going to reproduce, or try to reproduce, the exact same sound that it captured. And it's that simple. So it can get very complex, but that's a very simple understanding, just the basics of what that analog signal is. So I hope that was very helpful and you enjoyed the video, and peace, hope, love.